Hello and welcome. The focus of this lesson is on solution controls. Ansys Fluent uses iterative schemes to solve the set of equations and calculate the solution. These set of equations are highly nonlinear, and in order to stabilize the solution calculation, Ansys Fluent makes use of a technique called under-relaxation. The control section in the solution tab is where the necessary under-relaxation settings are defined. Additionally, here we can also define which equations to solve, what limits to set for solution variables, and other advanced settings. Without any further delay, let's get started with our lesson. We will use an example problem for our discussion. Open Ansys Fluent in solution mode. Go to File, Read, select Case and pick the provided case file. All the upstream steps have already been performed, and so we can directly go to the Solution tab. One of the groups in the Solution tab is the Solution Controls. Clicking on the Controls option in this group opens the Solution Controls task page. The major setting in the controls page is the under-relaxation. Let's talk about this first. As mentioned earlier, under-relaxation factors are used to stabilize the solution calculation process in Ansys Fluent. There are two types of under-relaxations, explicit and implicit. Explicit under-relaxation is when the solution update between iterations is moderated by a specified factor. The idea is that if we take the value of some solution variable, here called phi, the solver will compute a value for phi at the current iteration starting from its value at the previous iteration, which is the way that iterative methods work. There will be some difference between the value computed by solver in the current iteration and the value from the previous iteration. Let's call that difference delta phi. In explicit under-relaxation, instead of the entire delta phi being added to the all value of phi, only a selected amount is added, which is controlled by a factor called the under-relaxation factor as seen from this equation. Ansys Fluent does this in such a way that higher under-relaxation factors close to 1 allow the solution to change more quickly from one iteration to the next. So in theory, the solution would converge in a smaller number of iterations. But if the under-relaxation factors are too high, solution stability can be significantly impacted, leading to a divergence of the calculation. Reducing the under-relaxation factor should result in enhanced solution stability. However, the downside is the increase in iterations for converge. The default settings are suitable for most of the problems. However, we can always change the values when necessary. It is important to note that the final converge solution is independent of the under-relaxation factors, that is, the solution does not change because of the employed under-relaxation value. For a steady-state CFD simulation with pressure velocity coupling set to its default, that is coupled and the pseudo time method is turned on and set to global time step, explicit under-relaxation is used for all the equations involved in the calculation. The default values of the factors used can be seen in the solution control task page in the field next to the name of each equation. Next, let us talk about the implicit under-relaxation. Implicit under-relaxation is basically introducing a stabilization factor directly into the discrete set of equations that are solved. This is the default approach for implementing under-relaxation for equations in steady-state simulations when pressure-velocity coupling is set to any other method other than coupled. The factor that is used for each equation is listed in the solution controls page. As with the explicit under-relaxation, the closer the value to 1, the lower the under-relaxation. When the pressure-velocity coupling is set to coupled, the implementation of the implicit under-relaxation by default is by using the pseudo-transient method. The controls for this pseudo-transient method are available under the Run Calculation section. These are advanced settings and require deep knowledge of the inner workings to modify. A discussion on these is beyond the scope of this lesson. If pseudo-transient is turned off, then implicit under-relaxation is true, specifying a floor current number for all the equations that are solved in a coupled manner, and through the standard under-relaxation factors for other equations. For more information, refer to the user and theory guide. Under the controls group, we also have additional features like equations. Click on Equations to open the Equations dialog box. It essentially contains the list of equations that Ansys Fluent solves for the defined model. It is possible to unselect specific equations to ask Fluent from solving them. Let us now click on Limits to access the Solution Limits dialog box. In order to keep the solution stable under extreme conditions, Ansys Fluent provides limits that keep the solution within an acceptable range. You can control these limits with the Solution Limits dialog box. Typically, you will not need to change the default solution limits. There is also an Advanced tab available under the Controls group. When you click on it, it opens an Advanced Solution Controls dialog box which allows you to set the parameters related to the multi-grid, multi-stage, and non-iterative solvers that are used under the hood to solve the set of equations. For more information, refer to the user guide. To summarize, in this lesson, we discussed about the purpose of solution controls, explicit and implicit under-relaxation, and the role of under-relaxation factor in stabilizing the solution calculation for a steady-state pressure-based solver. We also briefly talked about equations, limits, and the advanced option in the Controls tab. With this, we come to the end of our video.